Sorry for that. Where were we? Can I even remember anymore? Where were we? I have to open. Okay, so we were talking about the collisions. Okay, so we say we're only going to discuss the two types of collisions. This is gonna look at elastic collisions. In elastic collisions, where we're gonna bring in perfect inelastic collisions. Okay, so with the elastic collision, so when the objects comes together, so when the objects interact, each of that object bounce off from one another. Okay, so from each other, and the kinetic energy of that collision is conserved, which means that the kinetic energy before and the kinetic energy after the interaction, they are all equals to, they are the same. Okay, so before and after, the kinetic energy is the same. Okay, while in elastic, okay, before we go with that, here we have types here. So when I was saying, okay, they bounce off from one another, you can see from this first point, you have a moving object bumping to a rest object. Okay, so they come together, so they interact. So the moving object stays at the rest, while the one that was at the rest starts to move. Okay, we have an object that comes, they were traveling in, they were coming together, facing one another. Okay, they collide, then each of that object bounce off in the opposite directions. They don't stack together and move together. Okay, while we have the ones moving in the same direction. So we see that the ones that are moving in the same, where am I? Moving in the same, what are my notes? Okay, moving in the same, you can see here they are all moving, it's facing the same direction. So they collide, so they continue to move in that directions. So they don't stuck together in the elastic collisions. Okay, so we are saying that, okay, so imagine you have two objects of mass 1 and mass 2, okay, both moving with the initial velocity 1 and, okay, and then the velocity 2, and then they undergoes an elastic collisions. Okay, what are their final velocities after collisions? Okay, so we say that in the elastic collision, the kinetic energy is conserved. Okay, so we have that the kinetic energy before and the kinetic energy after is the same. Okay, so and we said that the momentum is also conserved. So we said, just dealing with the closed system, so then we have that the momentum before the collision is equal to the momentum after the collision. Okay, so it means if we consider the the kinetic energy. This is kinetic energy, which is half the initial velocity of first object times its mass. Okay, so using that, if we cancel out 2, okay, multiplying by half on both sides, multiplying by 2 over 1 on both sides, it cancels out, and then it simply simplifies to that equation, okay, where we have m1 v1 initial squared plus the m2 v2 initial squared should be equals to the the kinetic energy after their collisions. Okay, so doing the manipulations, so we then from this we just simply group the ones that have the same same variable. So we have that m1 v1 initial velocity of that first object squared plus the m2 v2 initial velocity. Okay, initial velocity. What is happening today? Okay, initial velocity this is initial velocity of the two is equals to the momentum of, the velocity after the collision plus the of the first object v1 final squared. Okay, so from here we group the ones that have the same value. So m1 goes with the m1 and then the m2 goes with the m2. Okay, so we have that m1 initial velocity 1 squared minus, we are moving this to this side, m1 final velocity 1 squared. It's going to be equals to, keeping that on this side, m2 v2 final velocity squared minus the m1 v 2 not 1 2 v2 initial squared. Okay, and this one here, this part here, it's the same as, I want to have the initial velocities comes first, is the same as minus, okay, you bring this one first, the m2 v2 initial squared minus the m2 v2 final squared. What I did is just to multiply this side with a negative 1. Okay, so now we have an equation m1 v1 squared initial minus m2 m1 v1 final squared equals to minus the m2 v2 initial squared minus the m2 v2 final squared. What do we have? We have something in the form. Now what we have here, we have a squared. If I just write this, okay, we have something in this form, a squared minus b squared. What is this equal to? This is the same as a minus b. You multiply this with a plus b. So this is this one here is equivalent to the multiplication. Okay, the two, if we factorize this, is equals to that in the opposite directions. Okay, so it's have a minus b times the a plus b. If you multiply this out, will give you back here. So it means this one here we can write it in that form. So it means we have m1, okay, v1. You can factor m1 out and then you just have it like that. v1 initial minus the v2 final, V1 final, okay, times the V1 initial plus the V2 final, okay, equals to, we do the same on this side. Okay, so we have now M2, we can factor out M2, it's a minus, let's not forget the minus there, can factor it out. Then we write it also in that form, V2 initial minus, please log in, the meeting will end in 10 minutes, log in so we can finish this part. So it's V2 initial minus the V2 final times the V2 initial plus the V2 final. Okay, this height is equals to that one. Okay, so then from the momentum, we have that M1, conservation of the momentum, M1 V1 initial plus the M2 V2 initial is equals to the M1 V1 final plus the moment M2 V2 final. Grouping again the ones with the same values, so then we have that M1, okay, we have V1 initial minus the V1 final, okay, taking this one to that side and then factor out M1 equals to minus the M2, okay, V2 initial minus the V2 final. Okay, so taking this one here to this side and multiply that one with a negative 1. Okay, so if we have that, then we can do from the first, the kinetic energy, where we have M1 times those values, V1 initial minus V1 final times V1 initial plus the V2 final. Okay, V1 not 2 equals to minus M2 V2 initial minus the V2 final times the V2 initial plus the V2 final. Okay, so dividing this equation, you are now going to divide this equation with that equation. Okay, so you're going to divide this equation with that equation. Okay, so if we divide that equation, remember we have M1 V1 initial minus the V1 final, okay, times the V1 initial plus the V1 final equals to the minus M2. Just continue writing those values. So you are going to divide that, okay, on, remember we have now each equation on equal side. Okay, so here you're going to divide with M1 V1 initial minus the V1 final. Okay, we have equal sign there. We divide this side with the minus M2 V2 initial minus the V2 final. This is what we have. So by dividing that, you see that the M1 cancels out. Then this one here cancels out with that one. So we do the same on this side, equal sign. Then this one cancels with it. And also where there is V2 initial cancels out with that value. So it means we're left with V1 initial plus the V1 final equals to the V2 initial minus, plus the V2 final. Okay, so we have that equation here. It is very important. So it means it's saying that, so it means, okay, so we have that this one here equals to that one there. So if we can write this in the form of the initial velocity grouping together, the initial velocity and the final velocity. So we have that the initial velocity, which is V1 initial minus the V2 initial, it's going to be equals to the V2 final minus the V1 final. So you can make use of any of this depending on if you know one of the values. So if you don't know both of them, you simply make use of these equations with the kinetic, with the conservation of momentum, and then you can solve for one of that values. Okay, so because you're gonna have two unknowns, where you have two equations. So you have this equation and the first one from the momentum, conservation of the momentum. Okay, so this is what we were doing here. So we have that one equals to that. Okay, so we have V2 initial minus that. So we have that equals to that. Okay, so if we group that, so we have, this is what we have, the V1 initial minus the V2, V1 initial plus that and that. So if we group them together, and if you want to bring up the first, maybe you want to say, okay, I want to take my first value, which is the first, from the first object, V1 final minus the V2, we'll multiply that equation with that. So if we do that, then it means that that one, the relative velocity or the final velocity, okay, so the velocity of the change in velocities of the two objects before collisions, okay, before the collisions, is equals to the negative velocities of the two objects after the collisions. So it means this is not a surprising result also, because if you look up here, okay, let's say, okay, when you have, if you look up in here, into this one here, okay, so it says that the initial velocity, okay, so it means if you take the final, the velocities of the first before the collisions, it's going to be equals to the negative, the difference between the velocity, between the two velocities of that, the same object that went through the colliding. So as you can even see here, because these objects, like this one here, this one was changing. This one, the first, the blue one is one that is moving, that going in an object that is at the rest. Okay, then later that energy that was on the blue ball, it gets transferred, it gets to that energy, to the kinetic energy of the final, the one that was at rest. So if you take if you just calculate the velocities before that and calculate the velocities after that, then you will see that, okay, then the velocities here, the relative velocity, when you sum up the two, it's equal to the negative velocities of after the collisions. We have less than 1 minute. Please log in back so we can finish up this. Okay, so with the inelastic, with the inelastic collisions, we'll come maybe to start with this one, but I can touch it a bit. So it's when we have, when the objects comes together, or they collide together, the energy, the kinetic energy of that object is not conserved. So even though the mechanical energy, remember when you're talking about the mechanical energy, we refer to the potential energy and the kinetic energy. The mechanical energy of that object is conserved, but the kinetic